I recently built an app in Dify connecting 2 large language models and 3 different workflows. I thought, this is going to be amazing, and it was until I saw the bill. It exploded. I was staring at the numbers, completely stunned, thinking, where on earth did all this cost come from? This experience forced me to dig deep into a question that many of us in the AI space are grappling with. Where exactly does the cost, or as I like to call it, the freight cost of running these powerful models come from? It's not as simple as just paying for what you see on the screen. Today, in episode 44, we're diving into this mystery. I'm calling this one. I connected 2 models and 3 workflows in Dify, and my bill exploded. We're going to break down the cost structure, understand the relationship between token counts and what I call call multiplication, and figure out why our expenses can spiral out of control. To really get our heads around this, let's use a powerful analogy, the logistics industry. Imagine you need to send a package from one city to another. A single, simple call to a large language model is like hiring a truck for a single trip. The cost of that trip depends on 2 things: the size and weight of your cargo, which is like the number of tokens in your input and output, and the distance it travels. The truck driver charges you a certain price per mile, just like the model provider charges a price per token. So the cost for this single trip is straightforward. Your total cargo size, meaning your tokens, multiplied by the unit price per token. Simple enough, right? This is the most basic form of cost, a single delivery, one and done. But what happens when the delivery isn't just a straight shot from point A to point B? In the world of logistics, complex deliveries often involve multi-leg transport. Your package might go from your local warehouse to a regional hub, then get loaded onto a long-haul truck to another hub, and finally onto a smaller delivery van to reach its destination. Each of these legs is a separate trip with its own cost. Now let's bring this back to AI applications. A complex workflow in a platform like Dify is exactly like this multi-leg journey. What you think of as a single request might actually trigger a chain of operations. Each step in that chain is a separate leg of the journey. For instance, the first leg might be taking your initial query and sending it to a model to rewrite it for better clarity. That's one trip, one cost. The second leg could be using that rewritten query to retrieve relevant documents from a database. That's another trip, another cost. The third leg might involve sending the query and the retrieved documents to the main model for the final answer generation. And that's yet another trip, another cost. Each of these steps, whether it's input-output, or calling a specific tool, is an individual transaction with its own associated cost. So the total cost is no longer just about one trip. It's the sum of the costs of all the individual trips in the chain. Your total freight cost becomes the number of calls multiplied by the unit price for each call. This is where things start to get expensive, and it's the key to understanding my exploding bill. So now we arrive at the core insight, the real culprit behind runaway costs, what I call call multiplication. When you look at your bill, the shocking number isn't coming from one single, massive, expensive generation. The true cost driver is the sheer number of calls being made behind the scenes. Think back to our logistics metaphor. You're not paying for one giant cross-country truck journey. You're paying for a whole fleet of smaller trucks, each making a part of the journey. In an AI workflow, a single user prompt can trigger a cascade of events. First, there's the retrieval step. Your system might make a call to an embedding model to understand your query, then another call to a vector database. That's 2 calls already. Then, it might need to rewrite your query to make it more effective for the model. That's a 3rd call. After generating a draft response, you might have an evaluation step where another model checks the quality of the answer. That's a 4th call. If your workflow uses external tools, like searching the web or accessing a calculator, each of those tool uses is another separate call. Before you know it, your one simple question has resulted in 5, 6, or even 10 distinct calls to various models. Each call consumes tokens, and each call has a price tag. This call multiplication effect is the silent budget killer. The number of calls dramatically amplifies the total freight cost, turning what seems like a small task into a surprisingly expensive operation. It's not the size of one package. It's the number of trips you're making. Alright, so we've established that the total cost, our freight cost, is fundamentally driven by 2 factors: the size of the load, which is our token count, and more importantly, the number of trips, which is our number of calls. We're paying for a fleet of trucks making multiple deliveries, not just one. This naturally leads to a critical question. If making many separate trips is so expensive, is there a way to be more efficient? In the world of logistics, if you have multiple small packages going to the same general area, you wouldn't send a separate truck for each one. That would be incredibly wasteful. Instead, you'd use a strategy like carpooling or consolidation. You'd combine all the packages into one truck to make a single, more efficient trip. So can we apply this carpooling idea to our AI workflows? Is it possible to bundle multiple steps or requests into fewer, more consolidated calls to the model? Can we reduce the number of trips our virtual trucks have to make, thereby slashing our costs without sacrificing the quality of the output? This is the puzzle we need to solve. Exploring these carpooling strategies for cost optimization will be the focus of our next discussion. We'll look at practical techniques to batch requests, chain prompts intelligently, and design more efficient workflows. So make sure you stick around for that. Thanks for watching, and don't forget to like and subscribe for more deep dives into the world of AI. See you next time.